Okay, if I were to ask you to go find the antiderivative of x to the third, basically I would be hinting to you that this x to the third is a derivative of some function, and that I wanted you to go and actually find that function, okay? So mathematically, the way we say, hey, go find an antiderivative is like this. And you might have seen that before. It's the integral symbol, and it's an elongated S, actually. It means sum, maybe. But that just means, hey, go find, give me the function that will produce this derivative right here, okay? So it turns out that, just like, well, notice that this is it's an exponential function, okay? It's x to the third power, and we had a power rule to find the derivatives where we just slide the 3 down, subtract 1 from the exponent. There's also a power rule for an antiderivative or an integral, okay? So I might as well just throw that out there right now. Okay, then the generic version, we'll just use n, okay? But what that is, okay, that's going to be x to the n plus 1, then n plus 1 in the denominator, plus c, okay? Alright, so let's test that out real quick with our x to the third here. So, and by the way, there's also another notation. Once you have found the antiderivative, just to distinguish it from, just regular functions, we tend to use a capital F. Okay, so if I said, hey, find the antiderivative of x cubed, we'd start out, we'd write big F of x, and then we'd just use our formula right here, okay? So I'm just going to write x to the third, I'm just going to write it out, and then I'm just going to go ahead and add the 1 to it, okay? Then I'm going to divide by the same thing, 3 plus 1, and I'm going to include this arbitrary constant right here, and we'll show, I'll show you why we do that in a minute. Okay, and for simplification purposes, we would arrive at x to the 4 divided by 4 plus c. Okay, so big F of x is equal to x to the 4th over 4 plus c. Okay, and that would be called the general antiderivative. Okay, now remember, I basically said that this was a function. Okay, so if I differentiate big F of x, if I differentiate the antiderivative, I should get x to the third, okay? And this is actually part of the definition of what an antiderivative is. So if I want big F prime of x, okay, and that's this over here, okay, I'm just going to use my derivative power rule. Okay, I write the exponent in front, subtract 1 from the current exponent. And then remember, this is a constant. It could be 1, 2, 3, 4, 5. It doesn't matter, because if you take the derivative of a constant, it's 0. Okay, and that's one of the reasons we use just a plain c, is because it could be 1, it would still be 0. It's still going to be 0. 2, it doesn't matter. Okay, so let me cancel these out, and I end up with x to the third. Okay, so that's how you know that we found the antiderivative. And going back to this part right here, this could have been 1, it could have been 77 gazillion, and it still would have been 0. So that's why we just use c, and we don't even bother with writing some of those things down like that. So that basically is the power rule for antiderivative. So I think let's actually get a real example here, okay? And okay, so your first antiderivative, maybe it's not your first, but the first thing I want to know about this is, notice how this is just, a sum of 2 functions, okay? And also notice that there's no exponent on this whole entire thing, okay? This is a very simple example of exploring antiderivatives. Okay, and when you first start this, I think the best way to go ahead and do this is to just do it term by term. Okay, so that just means I'm gonna find the antiderivative of 3x. Okay, so there's a notation, and I'm gonna add it to the antiderivative of 5x squared. Okay, so basically that tells you right away that you can take antiderivatives and you can add them together and end up with, a general antiderivative in the end. Okay, so let's see here. Let's go ahead and use the power rule right here. So big F of x would be equal to 3. Really, there's that's just really x to the 1, so it's just 1 plus 1. Okay, then we divide by 1 plus 1. And then we're going to add 5 x to the 2 plus 1. I'm just adding 1 to it. Okay, and then we're also going to divide by the same. Okay, and I also want to take my constant. I'm going to put that on there too. Okay, so let's go ahead and do some more simplification to this. And we'll have something that looks like 3x squared over 2 plus 5x to the third over 3 plus c. Okay, so that's our general antiderivative of 3x plus 5x squared. Okay, so let's differentiate this and make sure that we get this. Okay. So f prime of x, I just use my power rule, so I put the 2 in front, that just gives me a 6. Okay. I better make sure I get the paper up there. I use the power rule again for derivatives. Okay. And then, the derivative of the constant is just 0. Okay, so now all I have to do is simplify. Okay, because 15 divided by 3 is 5. So yes, the numbers match. And I was always told that, you know how we went back through here and we used the power rule all over again? We did the antiderivative, then we took the derivative. It's really easy to get confused and do the wrong thing. Okay, so if it's not adding up, you probably you're used to doing derivatives by now. And really, I didn't really have a problem with that. I just went through and I started doing antiderivatives and they worked fine. I didn't have a problem with it until I got into differential equations, which is down the road, and then I started doing it. So, I don't know, go figure, but it'll get you sometimes. So next video we'll probably work on some other types of functions, okay? Maybe some trig function antiderivatives.